How do we write a conclusion in science class? When we're in science class, when we write a conclusion, we're going to use a format called CER. C stands for claim, E stands for evidence, and R stands for reasoning. So first thing you got to do is make a claim. A claim simply answers the experimental question. So for example, if my experimental question were, does listening to music during a test help a student score better on a test? My claim is just answering that question. What I find out. For example, listening to music while testing decreases student test scores. That's what I discovered in my experiment. If you were testing a claim, or if you were testing an experimental question that was something like, how does temperature affect reaction rate? Your claim would be, when I decrease temperature, reaction rate increases, or whatever you found in your experiment. Okay, so after you make your claim, then you got to give evidence. Evidence is just how can the evidence from your experiment prove the claim you just made? Generally, it's going to be quantitative. Quantitative just means it's numbers. It's going to be numerical evidence. So for example, my claim, listening to music while testing decreases student test scores. My evidence, students who listen to music scored 10% lower on their math test than students who did not listen to music. That's my evidence. And there also, in general, there'll probably be a little more evidence than just that. Lastly, so we have C, we have E. Our last one is reasoning. How does this evidence prove your claim? Why did you choose this evidence? So basically, this is like tying it all in at the very end. So I would say something like, this proves that listening to music decreases test scores because it shows that when all other variables are kept constant, whether or not a student listens to music drastically affects their test scores. So I'm kind of explaining the evidence, why it proves my claim, maybe even why I chose that evidence. Even if you're talking about the rate of a reaction, your reasoning could also involve you could tell me like what we learned in class, what's happening during a reaction with the atoms bumping around, right? And trying to collide with each other in just the right way to react. So that's the reasoning. Also, it's always important in the conclusion section to talk about any possible sources of error in your experiment. That just means what could have gone wrong, what could have been improved if you did it again in this experiment. So an example of this with the music one, let's just say during the test, the students listening to music might not have heard my instructions for them because their headphones were in their ears. If I perform this experiment again, I would make sure those students start listening to music after they get their instructions from me. As a couple of tips, this guys, often possible sources of error often involve human error, like mistakes we make, like, oh, I accidentally did this when I should have done this, whatever. Or it could also involve things that are not kept constant, right? Constants are so important in an experiment. If they're not kept constant, let's say you're testing the rate of an Alka-Seltzer reaction and you split an Alka-Seltzer in half, but one's Alka-Seltzer half is a little bigger than the other one. That's something that's not kept constant. So that's a possible source of error in your experiment. Go ahead and get started on your conclusions now.